Hello, this is Mr. Boyer. In this video I'll be talking about cube roots. So first we need to know that the product of three equal factors is the cube of a number. So if I said 5 times 5 times 5, we would write it as 5 with an exponent of 3, and we call that cubed. So 5 cubed, which is 125. So what happens if we take we already know the volume. Let's say if we know the volume of this, that was a horrible representation of volume, and we want to know what each one of those sides is. So we would have to be doing the opposite of what we just did. So the opposite of cubing a number is taking the cube root, and we write it like that. It's just like the square root sign, but we throw a fancy little 3 up there to know that it's a cube root. Let's do a few examples of cube roots. So let's say if we take the cube root of 27. So the first thing you need to do is make a pretty little factor tree. Unless you memorize all the cube roots, which I don't know who does, but some people probably do. I would make a factor tree, and we say we know that 3 times 9 is 27. And I know that I can branch this 9 into 3 times 3. And we can't go any further than that. So what we're doing, since it's cube roots, we're looking for groups of 3. Any number that comes in a group of 3. So here's 3 3s. So I know that the cube root of 27 is 3. Let's do this for this next problem. I can break this up into 5 times 25. And then I can split 25 into 5 times 5 is 25. Here we have a group of 3. I can't go any further. So my square root of, or cubed root, excuse me, of 125 is 5. Let's do one more example, a little more difficult. Let's take the cube root of 64. Well, most of us know that 8 times 8 is 64. And I can split 8 into a 4 times 2. I can split this 8 into a 4 times 2. I can split this 4 into a 2 times 2. And that 4 into a 2 times 2. Again, we are doing the cube root, so we're looking for groups of 3. There's a group of 3. And here's a group of 3. So we multiply those. And we have 2 times 2 is 4. So the cube root of 64 is 4. Hope that helps. Bye.